Hello and welcome back to the next part of this series. And at the last time we set up our components. We started with the value component and then we derived from that the leveled value component and added some values and functions to it. Now we're gonna continue making them a little bit better, improving on them and create further components. First we go into our value component that we created in the beginning and make a little change to it. Make that input name a little bit better descriptive. I called it new value, but since it's actually adding that to the value, it's actually a delta. Let's call it that. It's the delta amount that we either add or subtract to our value. Let's compile that. Close that out. So in our leveled value component, we implemented the level ratio function, which is good, and which reminds me that for this function as well as the get percentage function, we set them both to be pure functions, since they don't modify any values in our class. They can be perfectly pure. This function, however, does set a value in our object, so this one will not be pure. This one needs to have an execution wire that comes out of it. So we continue with some more functions here. The same way we have implemented the set value function, which is inherited by this one, or rather update value function. We create now the same here for the level. We set another function up and call it set level, or rather update level. This again has an input, which we call just level. That is by how much we intend to increase the level. So usually it will always be 1, but let's keep that flexible. We get our level max and we get our level. Then we take that local level and add it to, not multiply, add it to this one, and that will also set the level. And when we compare that here, we don't need a high bound or low bound, because there won't be a low bound. Levels will always go up, never down. And so for the result, whether that works or whether we hit the ceiling, we can just use a normal Boolean as a result type. So we just compare that now. If that is greater our level max. So at this point we have to remember then, or consider that we have to set the level max one numeric value higher than what we allow here, because we want to level up until that value, but everything above then should not be considered. We branch off here. And again, this is all logic then that can be refined if we have a better solution, or if we find that we can do something more efficiently. That's why it's all split up into its different function, so it's easily accessible and also interchangeable. So in the case it's true, we have to set our level, set level to the level max. Not set the level max, but get the level max and set the level to it. So if it's already there, it stays there. And our return value, we can set that up now as well, is the success, and it's the Boolean. So if that happens to be larger and we cannot level up, we have no success. And in the other case, where we could level up and are still below the level max defined here, we have already set our level, we return a positive success. So that is it. Do we need a function else? Let me just think. So now we can work on our next component. We close that one out and right click again on our leveled value component, and we create a child, and we call this the stats component. Those will be the components that have a reference to a stats bar widget. Again, we can see all our inherited variables and functions that we have. And here also the parent functions are linked in for our events by default. We're also going to use that later when we override some of our functions ourselves. But let's first set up what the stat component makes a stat component. That is the value for stats bar widget, and it's of the type radial bar widget, and we go for an object reference. We don't provide anything at default. It's kind of pointless. We don't have anything outside in gameplay where we could fill this with, so it's not statically linked to something. And now we have another function for that we can fill. It's called the update widget, or we call it update stats widget. And inside this function we take that widget when we have one, we check that by isValid. If we make really sure that we always call this function only and only if we have a reference, a valid reference assigned here, we could spare the isValid node, but it's a bit better to have that in there anyway. So we have our check if the widget is actually existing and valid. We go from there and call the update value, and there I see I named in the radial bar my update function update value, and not to get confused with the update value function that we have here in our class, I just go to my widgets and select my radial bar widget. I open that up, I go to the functions graph, I go to my update value function, and I simply rename it and call it update display. Save that. And here in my function now, call update display, so there's no confusion with any update value called. And if it's valid, I can hook it up. And the value, nope, it's not the value that goes in there because we have a high bound and a low bound. We simply call our function get percentage. Since it's an inherited function, we cannot just drag it in like we would with a function that just exists in the same class. So we have to search it from here. It's under call function. We call the get percentage. That's what's coming from our value component that gives us the percentage. And we go in here. If we double click it, takes us right to it. So let's compile and save that. So that is the update widget function. So every time now we would update a value, we would need to call the update value function and then the update widget function accordingly. But I want to have this value, or I want to have that done automatically, that whenever we change this value, we want to also update the display. Now when we implemented this update value function in our, let me just open that again up. When we implemented that in our function here, in our component here, in our value component, there is no way of having something to access a widget display. That just was introduced in a class higher up. So when we want to still be able to call our update value function that updates the values and all that stuff, we need to work here with this parent construction, which just got created when I click there on it. So here we override the function. So every time for a stats component we call update value, this thing here will be called, which in turn calls our parent function and then continues executing. It just takes the value from our delta here and passes it on to the parent function. And also our output parameter is here supplied, which is called here new parameter because we haven't named it yet. Call this bounce result. I have a proper name for that. Yep, now we get a little error here till we reconnect that. So at the moment we're doing not much in our overridden function. We just pass it on to the parent function and leave it at that. But since we have our widget now, we put that in there. So after we set our value, we grab our value and update the display with it. So now a simple call to update value in this class will automatically make the stats bar widget update, which is good. That's what we want. And now that is done, now we create another child from that. We call it the attribute component, and in there we add another widget reference. This will be called the attribute bar widget and of the attribute bar widget type. Again, we don't supply a default value, and here in this function, in this graph, we update the update level, which will basically work just the same way. We update our level, and now we get our attributes bar widget. And when we take out from it to an update function, we will see that we don't have them because we haven't implemented them. So let's go to our attribute bar widget and do that real quick. We go over to the function graph and add to function. We add the update value bar function, which will just receive the new bar value, the new level ratio. So it's float, and we go to our value bar, grab it, and set the percent to that. It takes care of that. Then we create another function called update cost label, which will get an input integer that is the new costs, and we grab our cost label, get, and set a text. Then we convert that to integer. That's nice. And that is that. The reason why we have these function instead of like grabbing them here from this one, we could also access it like this. So we get our attributes widget, we grab the value bar, and then we could also set the percents from here. If we change something on later here in terms of how that value bar is there, so let's say we put it into another widget and then that combined widget into here, we would have to go here and to all the other places where we access the widget and change the way how we retrieve the reference. And so since it's now just an update function here, then we can just call it and we don't have to care on how that widget is built up internally. As long as this update function knows what to do, everything will work fine. So we call our function, and it's the level ratio that we get. Let's compile that and create our update cost function for the costs that have to be upgraded or included. See if we have something that we can override. Nope, we haven't included that here in our function. We have nothing for the costs. Let's implement that quickly here. So we add a function. We call it update costs. It will have an input. The new costs, integer, and we set the costs, and we're not checking for any high bound, low bound, or what we exceed. We're just checking that it's not, or we care for a low bound in terms that we're checking that it's not below 0. So we get the new cost and compare them. If they are equal to 0, we branch from that. And if they are 0, we set them to 1. That is the minimum cost that we have. Or actually, better check it greater 0, so we don't have any negative costs. It has to be really greater than 0. Then this goes to the false if it's not greater than 0. And otherwise, costs will be our new costs. Put it like this. Pile. We get a value. It's larger than 0. We set it. If it's not, we set it to 1. So that's the update costs in our leveled value comp. Now in the, let's close that out. In this one, we can now override it for our cost bar, cost button. Now we have it here as an event update. And you may now wonder, why do we have this as an event when we override it? But this one we have here as a function. So it's in a graph on its own. And we override that one, the costs. It's an event. What is the difference? Is there a difference? And why is there a difference? In the short form, there's no difference, no difference that would matter, but there's a difference in our functions. This one, our update level, is overwritten as a function because it returns a value. We have our Boolean success that we return. When we update our costs, we only supply a parameter, new costs, but we're not returning anything, neither here nor in the basic component where we implemented it in the first place. So we're doing stuff, but there is no return node. And that is the difference in the override behavior between those types of functions, those that return a value and those that behave more like procedures that do not have a return value. They end up here. So if we update our level here, calling the parent, updating that value bar and having here the returned node. And for our event, when we click on it, we get to the basic function. but that doesn't mean the code gets executed when we override it. That's why these two functions here also have a node to call their parent explicitly. So we add that for this as well. We right click on the function node and add the add call to parent function. Zip. And connect that like so. Now our overridden function calls the parent, and we go from here and update the costs. Didn't we create a function for that? Update cost label. Yeah. Update cost label. So every time we update the costs, the label gets updated along with it. Let's make this a bit neat. Compile that. So we have that for our costs and we have that for our level. There we update the value bar of our bar widget. So we close out the attribute component. Can also close out the bar widget. Go back to our components, save everything, always good. And now we create our next component. This will be based off the attribute component again, extending it further. And we call it the regen comp. Those are all the components that can regenerate, like health and stamina, or drain, like food and water. So we go in here, we have all our values, and we add another variable. We call it the regenerate amount, or delta, regenerate delta. It's a float type, and that basically defines the value that we add or subtract. In the case of regenerate, we add it, of course, to our value here until we reach the high bound. And normally that is not done by anything for the health component that would lower the health value. It would set on ticking true for this component. And then in our on tick event, we regenerate until we hit our high bound value. Thanks to our bounce results, we check that, and once we hit the high bound, we just set the ticking to false for this component. So we stop ticking, we only tick when it's necessary, and that will then stop regenerating because it's again at the full max value for that component. So let's do that. Here in the event tick for our regenerate component, we have already this parent tick in here. If we click it, nothing happens because it's empty. We did not override or implement it in any other component here down the line. Starting with our value comp, we don't have any on tick implemented here, and also in our leveled value comp we haven't anything here. So in this case we can drop that, we don't need it anymore. if we implement something in previous event ticks in the future, we can, as we did for our overridden function, always call the parent function again, and we will have that node back. So what do we do in the event tick? We take our value, we get it. No, we don't do that. That's precisely what we not do. We call our update value function. We see the target is the value comp. And if we click it, we're taken back in here where it calls the parent function, which is of course all our calculation stuff. So that's all called in that chain of overriding these functions in descendant classes. And we once we update this, then also the widget will continuously updating along with it. So we get our regenerate delta. That's what we want. And now we could do all this calculation in here, but I just decided that we create a special function for it. I like to have things compartmentalized in functions. So we create a function that we call do regenerate and hook that up to our event tick. So in case we do more than regenerating on tick, we can add that then here and have everything nicely and can see what is done at what point in our graph very easily. So once we tick, we go into our regenerate function and let's regenerate. We call our update value function. We call it with regenerate as a delta. And what we do then with our result here, we don't care about in this function because it's different for each component. The health and the stamina will do different things than the hunger or the thirst component. So we will then take care of that in those components individually and override the regenerate function there specifically for each component. So we'll leave it at that for the moment for that regenerate thing, and we close that out. And I want to leave it at that for this episode. That's a lot of stuff that was covered. Some things may be a bit complicated for a beginner, especially wrapping the head about that whole function overriding thing, how that works. So basically you can override a function in a descendant class and completely replace whatever that function is doing. That is then just implementing it. And so if we update, if we override the update value function and replace that with some totally different code, it will just replace everything. But that parent function call makes sure we actually care what the function is doing in its ancestor version. So we can either swap that out, or we can add something at the end, or we can do something even before. So if a descendant class has also this value and update value, and just wants to do some stuff before the call to the parent function, we can also add stuff in between here. So we're not limited to adding stuff behind it. We can also add stuff in front of it, however we see fit. So that's just for completeness here. And yeah, I leave it at that. Some people may want to watch that episode twice. You are welcome to do so and ask questions if they come up. Otherwise, see you next time in the next episode. And until then, see you. Bye.